welcome to the deep dive. You've brought us something really provocative this time.
Oh, yeah.
It's called Electromagnetism Deep Dive by Dave Champagne and 01. And the subtitle, Wow, Fields Were Never Real, Motion Theory Destroys the Illusion.
Yeah. Doesn't pull any punches, does it? That title definitely grabbed my attention, too.
Right. Tells you straight up we're going to be questioning some really fundamental physics ideas.
Absolutely. I mean, for, 150 years, we've relied on electric and magnetic fields, these invisible things that supposedly mediate forces.
The bedrock, really.
Exactly. And this source just comes along and says, maybe they're not actually real, not physically out there.
Yeah, the source suggests they might just be mathematical tools, useful for calculations maybe, but not the underlying mechanism.
Which leads us to this motion theory.
Right, and the core question it seems to keep asking, the one we need to focus on for this deep dive is, what's moving and what is the motion doing?
That's the heart of it. So let's try and answer that based on what the source presents.
Okay, let's dive in. Where do they start? Charge.
Yeah. They go right for the basics, electric charge. Normally, we think of it as just this property, right? Something inherent.
Like a little plus or minus sticker slapped onto a particle.
Exactly. Born this way.
Mm-hmm.
But motion theory says, nope, it's not a fixed property.
Okay. So what is it then?
They call it a motion imbalance.
A motion imbalance. Unpack that a bit.
Okay, so picture some kind of fundamental background motion.
Yeah.
Everywhere. All the time.
Like a substrate of activity.
Sort of, yeah. And a positive charge, in this view, isn't a particle with a positive label. It's a structure, some configuration, that causes this background motion to be pulled inward.
Pulled inward, okay.
And this inward pull increases something they call synchronization density.
Synchronization density, like things moving more closely together, more in step.
Precisely. Like dancers clustering and moving in rhythm. Now, negative charge is the opposite. It's a structure that pushes motion outward.
So it breaks up that local synchronization. Scatters the dancers, maybe.
You got it.
Yeah.
It disrupts the local pattern. So, crucially, these aren't static labels. They're dynamic states. Motion asymmetries, they call them, caused by the structure interacting with the motion.
Wow. Okay, that's a fundamentally different way of thinking about charge. Not something a particle is, but something a structure does to motion.
It really is. And it changes how you think about attraction and repulsion, too.
Right, because normally we think of forces acting between charges mediated by fields.
But here, there are no forces in that sense. It's described as synchronization pressure between structured motion loops. Basically, these imbalances are trying to resolve themselves.
Trying to find equilibrium.
Exactly. Opposites attract. Yeah. Because one pulls motion in, the other pushes it out. They can kind of cancel each other's imbalance if they get close, leading to more stable, synchronized motion overall.
And similar charges, like two positives.
Well, they both pull motion inward. Put them together, and they just amplify that inward pressure, disrupting the balance even more, so they push apart, seeking a less stressed state. It's about motion finding its most stable arrangement.
No invisible forces, just motion dynamics sorting themselves out based on structure and synchronization. Right? Quite elegant. In a way.
It has a certain internal logic, yeah.
Okay, so if charge is motion imbalance and attraction repulsion is synchronization pressure, what happens to the electric field? That invisible aura around a charge?
Well, motion theory is blunt here. It says the electric field doesn't exist as a real structure.
Doesn't exist. Okay. So what are we measuring then? What are field lines depicting?
They propose it's actually a synchronization gradient.
A gradient. Like a slope. A change over distance.
Exactly. It's not something radiating out. It's more like a map showing how the surrounding background motion tends to want to shift or reorganize itself to try and neutralize that central motion and to balance the charge.
So it describes the potential for motion adjustment in the space around the imbalance.
That's a good way to put it. It describes a tendency, the pressure for motion to reconfigure. The source is clear. No stuff radiating, no invisible push or pull. Any interaction is through this structured motion pressure, one area of motion influencing its neighbors.
Okay, the consistency is interesting. It's all motion, structure, and synchronization. Now, let's tackle electric current. The classic picture is electrons flowing, right?
Little particles marching through a wire, yeah. That's the standard model.
But motion theory must have a different take.
It does. Again, it reframes the electron itself. Not just a point particle, but a structured motion loop existing within the material's lattice.
Motion loops again. Okay, this seems key. And the lattice, the structure of the wire material.
Presumably, yes, and the underlying structure where this fundamental motion operates. So electrons are these localized, structured loops of motion within that lattice.
So if electrons are loops, what's the current? It can't be the loops themselves flowing down the wire, can it?
According to this theory, no. Current isn't the loops traveling. It's a chain reaction, a series of synchronized rhythm handoffs between adjacent loops.
Handoffs, like passing a baton.
Kind of. Imagine one loop starts oscillating or pulsing in a particular rhythm. Because it's connected or close to its neighbor in the lattice, it influences that neighbor to start pulsing in the same rhythm.
Like dominoes falling, but with rhythm.
Exactly. Or like a wave of synchronized clapping moving through a crowd. It's the pattern, the synchronized rhythm, that propagates down the line of loops. That's the electric current.
So it's the propagation of a state of motion, not the movement of individual things carrying charge.
Precisely. It's a wave of coordinated activity.
And voltage and resistance, how do they fit this rhythm model?
Voltage is described as the sink pressure pushing motion forward. It's the impetus, the thing that encourages the loops to pass along that synchronized rhythm.
The driving force for the handoff.
Yeah. And resistance, that's called loop friction. Basically, anything in the lattice structure that hinders that smooth, synchronized transfer of rhythm from one loop to the next makes the handoff less efficient.
Okay, so current is made of rhythm, not particles flowing. Voltage is sink pressure. Resistance is sink friction. That's quite a paradigm shift.
It definitely requires rethinking some core images we have about electricity.
And this naturally brings us to magnetism.
Right.
They're linked in standard physics, of course. How does motion theory handle magnetism? I remember the source quote.
Right, it's very direct. Magnetism is not a field. It's a loop of motion curved around flow.
Another field bites the dust, apparently. Okay, so loop of motion curved around flow. Let's break that down. Standard view first.
Standard view. Current flows in a wire, and poof, an invisible magnetic field appears, circling the wire, perpendicular to the current.
And that field then interacts with other magnets or moving charges.
Correct. But motion theory immediately asks that key question again.
What's moving?
Exactly. What's actually moving around the wire?
Yeah.
Because we don't see anything physically orbiting it. No little particles spinning around.
Good point. So if there's no field and nothing visibly orbiting, what is creating that magnetic effect we measure?
Their answer is that the magnetic field effect is actually a spiraling echo of synchronized motion. Or they also call it a motion correction loop.
Spiraling echo, motion correction loop. Okay, what does that mean in practice?
The idea is when you have that directional flow of synchronized rhythm, the electric current, it sort of destabilizes the background motion around the wire.
Right.
It disrupts the normal synchronization pattern in the surrounding lattice.
Okay, the current causes a disturbance.
Right. And to compensate, to find a new stable state, the surrounding motion loops organize themselves into a curved synchronization pattern around the direction of the current flow.
So the magnetic effect, the circular influence, isn't something generated by the wire itself, like an emission.
No, it's the response of the surrounding medium's motion to the directional flow within the wire. It's a structural adjustment in the synchronization pattern.
A feedback ripple, as they put it. Not a separate thing, but a pattern emerging in the existing motion field because of the current.
You've got it. It's an organized response within the synchronization lattice itself.
Okay. And how does this loop of motion idea explain why magnets attract or repel each other? No colliding fields allowed, right?
Right. It comes back to the interaction between the inherent motion loops that presumably make up the structure of magnetic materials.
So magnets have these built-in motion loops.
That seems to be the implication. And when you bring two magnets close, their respective motion loops try to interact, try to share or negotiate their synchronization.
Okay.
If the loops are oriented in a way that they align, where their patterns of motion are compatible, they can sort of merge or reinforce each other. They form a larger, more stable shared structure.
And that results in attraction, pulling them together into that shared structure.
That's the idea. Shared structure converges. Now, if the loops are oriented oppositely, their motion patterns clash. They disrupt each other's synchronization.
So they can't form a stable combined pattern.
Exactly. So they push each other apart, trying to minimize that disruption. It's repulsion, driven by the inability of their motion structures to sync up compatibly.
So again, it's all about how these fundamental motion loops interact and try to achieve synchronization. A loop-level motion negotiation.
Yeah, that's the phrase they use, yeah. No fields needed, just interacting motion structures.
This really seems to be pointing towards a unification, doesn't it? Electricity and magnetism often feel like two sides of a coin, but sometimes treated separately.
Absolutely. The source makes a strong case for unification at this deeper level of motion.
So in motion theory's terms, how are they unified?
It boils down to electric phenomena relate to directional motion imbalances and the resulting synchronization pressure gradients.
Yeah.
Think linear push or pull. And magnetic phenomena are the curved, looping synchronization responses that arise, particularly in reaction to that directional motion or flow.
So one is about the direct imbalance in its pressure. The other is about the curled up response of the surrounding motion to that directional flow.
Precisely. They're not separate forces or separate fields. They are just two different aspects or views of the same fundamental system, this underlying system of structured motion reacting and adapting.
It implies they must be intrinsically linked then. If you change one, you affect the other.
Exactly. Accelerate an electric imbalance like changing a current, and you naturally generate these looping curve responses we call magnetism.
And the other way around, if you mess with a magnetic loop.
If you deform or change one of these established motion loops, it should create imbalances in synchronization pressure, which would manifest as electric effects, like inducing a voltage.
So the things Maxwell's equations describe mathematically, how changing electric fields create magnetic fields, and vice versa, motion theory explains as just natural consequences of manipulating this underlying motion system.
That seems to be the claim, that interconnectedness arises naturally from the dynamics of structured synchronizing motion. It's all one system behaving in different ways depending on the constraints.
Okay, this is compelling in its attempt at simplification. But it begs the question, if this motion stuff was always the real mechanism, why did we invent fields in the first place? Why did physics go down that road for 150 years?
The source has a straightforward answer for that.
Which is?
We couldn't see the motion.
Oh, simple as that.
Pretty much. Think about the early days. Scientists saw objects attracting or repelling across empty space. They saw compass needles move near wires. There were obvious effects, but no visible cause bridging the gap.
No visible gears or strings connecting things.
Right. So lacking the ability to perceive or even conceive of this underlying structured synchronized motion that motion theory proposes, they needed something to explain the action at a distance.
And fields fit the bill. An invisible something that filled space and carried the influence.
Exactly. Fields became the conceptual tool, the mathematical framework, to describe these effects when the actual physical mechanism, the motion, was hidden from view.
So fields were essentially a placeholder, a model that worked mathematically but maybe didn't represent the physical reality.
That's the argument motion theory makes, that the real cause was always motion-structured, adapting, sinking under constraint. Fields were just the abstraction we created to cope with the invisibility of that motion.
And they use that phrase, 150 years of bad metaphors.
Yeah, suggesting that the field concept, while useful, might have ultimately hindered us from seeing the more fundamental motion-based reality underneath.
So the core shift they're pushing for is forget particles with static properties, forget invisible fields, focus on motion.
That's the essence of it. No particles in the classical sense, no fields, no forces, just motion, and the way that motion organizes itself into structures under various constraints.
And they give us, the listeners, a sort of mental tool for this.
Yeah, a direct challenge, really. They say, next time someone says field, ask them, what's moving?
To force a consideration of the physical mechanism.
Right. If the answer involves invisible fields acting on abstract charges, maybe that's still the old metaphor. If the answer can start pointing towards some kind of underlying dynamic process, some kind of motion, maybe that's closer to this alternative view.
It's a way to constantly check if we're relying on the abstraction or thinking about a potential underlying physical process.
Exactly. It's an invitation to break free from the field habit and constantly probe for the motion.
Okay, let's quickly recap the core ideas of this motion theory as laid out in the source material we've been discussing.
Sounds good.
So, first, charge isn't inherent. It's a motion imbalance caused by structure.
Check. Positive pulls motion in, negative pushes it out, affecting synchronization density.
Second, electric fields aren't real structures. They're synchronization gradients, describing how surrounding motion wants to adjust.
Right. No radiating stuff, just motion pressure.
Third, electric current isn't particles flowing. It's a synchronized rhythm handoff between structured motion loops in a lattice.
Yep. Current is rhythm propagating. Voltage is sink pressure. Resistance is sink friction.
And fourth, magnetic fields also aren't real fields. They are loops of motion or motion correction loops. curved synchronization responses to directional flow.
Correct. A feedback ripple in the synchronization lattice.
And underpinning all of this is that fundamental question.
What's moving? That's the lens they want us to look through. It forces the shift away from static properties and abstract fields towards dynamics and mechanism.
This has definitely been a mind-bending deep dive. Really challenges some deeply ingrained concepts about how the universe works at a fundamental level.
It certainly does. It asks us to potentially unlearn a lot.
It leaves you wondering, doesn't it? And maybe here's a final thought to chew on, something perhaps implied by all this, but not explicitly stated in what we covered.
Go on.
If this motion-centric view, this idea of reality being built on structured synchronizing motion rather than static particles and fields, if it holds water for electromagnetism, what might it mean for other areas of physics?
Like gravity. Or the nuclear forces.
Exactly. Could phenomena we currently explain with different fields or force carriers also be reinterpreted as different patterns or behaviors within some universal system of motion? Could the nature of matter itself, maybe even space and time, be fundamentally about motion and structure?
That's a pretty huge implication. Rethinking everything from the ground up based on motion dynamics.
It is, and even just thinking about everyday things, does seeing the world as a constant flux of interacting motion, rather than just solid objects with forces between them, change how you perceive reality? It's definitely a provocative idea to ponder.
A reality built on rhythm and flow, not just things. Definitely food for thought.
Indeed. Well, thanks for joining us on this fascinating deep dive.